Hello everybody and welcome to a chat from the engineering desk. Today we're going to be talking about sensor number 6 in the 36 sensors series, and that is going to be the Hall effect magnetic sensor. In this case we've got a digital sensor. In other words, the output is either a 0 or a 1. You get two types. You get the digital and the analog. An analog sensor produces a voltage in proportion to how strong the magnetic field is. In this case, it merely detects that the magnetic field is above a certain threshold and gives you an output. So, what we're going to do is wire it up together. So over here, I've got my Arduino Uno. It's plugged on into a shield. There's an Uno underneath it. A little breadboard. We have our little sensor. And there it is over there. Okay. And we have 3 wires for our supply and our signal out. Okay. So, let me just find the drawing here. What we're going to do, start off by plugging this in, like so. Try to keep it in shot. It's always a good idea. I've got to remember that you're doing this in front of a camera. It's a good idea to keep what you're doing in shot. But the more one practices with these things, the better you get at it. It becomes second nature. You know, it's like, why do I do this? Well, I was born into the world of engineering, electronics. My dad's an engineer. And that means that this sort of stuff existed at home. And I found it interesting, so I pursued the interest, which in those days meant buying kits and magazines, reading up, building stuff, soldering stuff together, playing with it and making it work. These days we have internet and an infinite resource of knowledge. Stuff to read, videos, project examples is absolutely unlimited. You can have so much fun. So I've wired up the Arduino. We've got 5 volts on it. It can work off 3.3 or 5 volts. So ground, 5 volts, and our signal to pin 2 over here on the Arduino. Okay, now you can see what I've done. So next up, we need to connect it to the PC and download some code and watch it work. The code is very simple. As always, having some code connected to it makes it more interesting. That's what the project is all about, is you're interfacing a sensor with some software and then you're producing an output, right? So let's bring in the USB cable over here. And flash up the Arduino code over here. Okay, so as you can see on the screen, we've got the code, which is simple. Let's quickly talk about the code. The Hall effect pin is pin 2, it's a digital input. Okay. LED pin is pin 13. So you can actually see it flickering underneath there each time the SIN transmits. Well, if I hold the magnet near it, you'll be able to see it turn on. Oh, we made a mistake. This is not working. Oh, what is going on? Oh, I made a mistake. I got the supply and the knot was mixed up. These things happen. Let's try that again. Ah, there we go. So, bringing the magnet near it. This lantern has two magnets in the base. That's what I'm using as a magnet. And conveniently handy. Is what it's detecting. So, about half an inch away and picking it up. And the light in there, Arduino, is coming on. Yeah, one's got to pay attention when reading the drawings and you're building stuff. Easy to make mistakes. Check your work. No harm done in this case. So we've got a variable which is Hall effect state. And then we make the LED pin an output. The Hall effect pin coming from the sensor and input. And we set up some serial comms. Then the code is very simple. We read digital pin 2 into a variable which is Hall state, and then if it's low we say magnet high. On the serial out we turn the LED on and I'll send a line feed or carriage return, which means that these appear in a column instead of a long row. It's neater and easier to follow, and it doesn't fall off the screen. Okay. Now you could have an else statement here as well. In this case, I prefer to do it this way. You separate it, the two states. So if the pin is high, we're not seeing the magnet. The LED is off. We print magnet low and send the carriage return. I've got a 1 second delay and the program repeats. And that is what's going on in the software. And it's commented as well. Always a nice idea to comment your code. And even yourself, you can go and read it afterwards and understand what's going on. It's like keeping notes. So it's good practice. So if you look at the screen, there you can see high and low. Very good. Typical applications for this, there are many. They used in motors to detect the position of rotors on brushless DC motors, proximity detection on a moving part, machinery, on security systems. You could use it to detect that a door is open or closed, or a window is open or closed. Any kind of moving part, and you want to detect where its position is, you use one of these sensors and a magnet. Got it. And I think that concludes our little lesson on 36 sensors number 6. For those who are new to this, I hope you learned something from it. I hope it inspires you to maybe think about playing with this sort of stuff yourself, sparks a bit of interest. Go read up with it, maybe get hold of someone, play with it. For the more experienced folks, you just happen to be here and you're following along, thank you very much. Those who wish to like the comment, please do so. You're welcome to comment below some of your own thoughts and experiences with working with sensors, not necessarily what we just did today. And if you want to see more, please subscribe to my channel. And remember to hit the notification bell so that you are warned when I've got some more interesting content out. And ladies and gentlemen, have an awesome day further. I'll see you for more. Cheers.